All right, so the last thing we did was example 3 yesterday. So let's do example 4. How about that? So it's right triangle. So all this stuff that we're doing is basically preparation for what we're going to do several lessons from now. All right, so it's not the end-all, be-all. Is that the expression? You ever hear that expression? Is that how it says? Okay, anyway, we're not done with trig just because we know a few of these little things, okay? This is all preparation for us to do other things. And basically for us to start solving things. Like today, we're not really solving for anything. We're not finding a missing side. We're not finding a missing angle, all right? All we're doing is just setting it up. We're just setting it up because in a couple, 3 lessons from now, then we're going to put it into practice. We're actually going to solve for stuff. We're going to find a missing angle. We're going to find missing sides and all that kind of thing, right? I mean, that's what math's all about, isn't it? All right, especially in geometry. Remember those days? All right, so here's what they give you. They tell you that this length right here is 10 centimeters, and this one is 7 centimeters. And this is angle P, angle M, and angle N. All right, and then what they want you to do, they want you to find the values of all 6 trig ratios for one particular angle, and they chose angle P. They could have chosen angle N, but they want you to do angle P. So I want 6 trig ratios. 6 trig ratios. All right. What I'm really concerned about is the first 3. All right. If you can get the first 3, then finding the other 3, which are inverse ratios, it's a little bit easier to do it that way. So let's do the first 3. Let's go in order: sine, cosine, tangent, right? SOHCAHTOA, might as well go in that order. So I'm going to find the sine of P, I'm going to find the cosine of P, and I'm going to find the tangent of P. All right. So we got to remember, what's our trig ratio for the sine? What over what? Opposite over hypotenuse. How can you remember that? That's the SO, S-O-H, right? So SOHCAH, C-A-H, TOA, T-O-A. So the sine is opposite over hypotenuse. Opposite what? Well, this tells you right here, that angle P. So this is my angle. So which side is opposite angle P? 7. Which one is the hypotenuse? Don't know it. So how are we going to find it? Pythagorean theorem, exactly. Okay, when they give you 2 sides, then find the third one, Pythagorean theorem. So, yeah, I think we got time because we don't really have a ton of stuff to do after this. Okay, have a good game. And I'll have the video up tonight. I'll do that right after school. All right, so what do we, let's call it, doesn't matter. Let's call it h for hypotenuse. Is that all right? So h squared equals what? 100 squared plus 7 squared, which is what? 149. And then you square root. So it's the square root of 149. What an ugly number. But that's what it is. It does not simplify. All right. So we're just going to leave it like that. So let's go back to the trig ratios. So I've got opposite over hypotenuse. And what is this? Square root of 149. Well, we got a little issue. What's the issue that we have here? Can't have a square root in the bottom, all right? So we have to get rid of it. You guys remember what the name of the I can't think of words. Do you know what we call it when we get rid of the square root on the bottom? Man, it's called rationalizing the denominators. Anybody heard that before? You never heard that before? Okay, yesterday I said it? Okay. All right, well, it's kind of an algebra 2 thing, but that's okay. Like I said, I'm here to teach you from scratch anyway. So the square root of 149 or over the square root of 149. We talked about this yesterday, right? So why can we do that? What's the reasoning? What's the rationale behind that? Just multiplying by 1. I can multiply anything by 1. That's fine. So now I want to write my answer as what? 7 square root of 149 over what? Just 149. It's an ugly answer. Okay, 7 doesn't go into this. We just leave it like that. and we're good to go. All right, why would they give you ugly numbers like that? I don't know. Well, I mean, life doesn't always have nice, pretty numbers, okay? A lot of times they work out to be ugly, so you got to get used to it, all right? So I guess that's probably what they're doing. All right, now the rest of it's pretty easy. The cosine of P, this angle, same angle, so it's what? It's what over what? It's adjacent over hypotenuse, so it would be 10 over the square root of 149. And you could probably figure this out without writing that down. What's that going to be? 10 square root of 149 over 149. Good. All right? So that's the cosine. We good? All right, let's do the tangent. What's the tangent of this angle? What over what? Opposite over adjacent. Ah, that's nice and easy. 7 over 10. 7 over 10. You don't need it right as a decimal or anything. Just keep it 7 over 10. That's good right there. Okay? Yeah. Now, the other three, remember, we've got to have 6 of them. Those are 3 of them. What's the inverse of the sine? It's the, do you remember? We did them yesterday. Look in your notes. I'm not going to answer you. You tell me. What's the inverse of the sine? What is it? Cosecant. Very good. It's the cosecant. How do we shorten the cosecant? C, S, C. It's cosecant. And we're doing the cosecant of P. Now, you could do this a couple ways. You could think, okay, cosecant is the inverse of the sine. The sine was opposite over hypotenuse. So what's the cosecant? Hypotenuse over opposite. You could do it that way, and that's perfectly fine. Or you've already figured out what the sine was, didn't you? Now, I wouldn't use this one. Use the original one, because what am I going to do to it? I'm just going to do what? Just flip it. That's right. So what's this going to be? Square root of 149 over 7. It works either way, doesn't it? Hypotenuse over opposite is the same thing as that. Or you can just look at what the sine was, just flip it, and you're good to go. Yes? All right. And then what's the inverse of the cosine? The secant, right. The secant of P. And then again, you could think, all right, what's the secant? It's the inverse of the cosine. Cosine is adjacent over hypotenuse. So the secant is hypotenuse over adjacent. That's fine. Or you could come back to this original one and just flip the fraction. Whatever way is comfortable for you. If it was me, again, this is not the right way. You do it either way. But if it was me, I'd probably just look at that fraction, just flip it. I just think that's a little easier, but however you want to do it. And that's over 10. Now, the cotangent is the third one. Cotangent of the angle P. That's easy. It's just, you flip it, it's 10 over 7. And there you go. So those are your 6 trig identities. They're going to ask you that every once in a while. Okay? It's not too hard, is it? All right. Now we're going to start something that, again, in and of itself, it's not super important, but it's going to lead you to something that's going to be really important. Okay, like I said, solving for missing angles and that kind of thing. So the numbers you're going to see today are the first of many, many, many times that you're going to see some of these numbers. Some of these numbers are going to look very, very familiar to you as you keep going through trig, all right? And this is your first time seeing them. You may have seen them, I don't know, we may have done this in geometry last year. I can't remember, but let's do this. This is going to feel like a geometry lesson because the first part is we're going to talk about 2 types of triangles, or 2 special triangles. One is a 45, anybody remember this? 45, 90 triangle. And the other is a, anybody remember? 30, 60, 90. Good. Okay, 30, 60, 90. Or some people might just say 45, 45 right triangle or 30, 60 right triangle. I don't know. I just like to put the 90 in there. Okay? Now, let's kind of draw one. I'll just do it by hand here without the fancy lines. Save me some time. Ooh, maybe I should use the lines. Yeah, there we go. All right. If this is 45, 45, 90, there's my 90, so this angle is what? 45, and this is 45, which also means what's true about the two sides? That side and that side would be equal to each other. Now, we had a little relationship. I know it's been a couple years, so you probably don't remember, but maybe you do. There's a relationship between the hypotenuse and the legs. Now, remember, both legs are exactly the same. Do you remember what the relationship is? Hypotenuse is the square root of 2 times one of the legs. Is that ringing a bell at all? Okay, yeah. Yeah, we did a lot of that. Well, not a lot, but we did a fair amount of that, okay, in geometry. It wasn't even in the trig part of geometry. It was just in like the regular part of geometry when we were doing right triangles, okay? So what does that mean? That means if I know one of the legs, let's say the leg was 5. What's the hypotenuse right away? 5 times the square root of 2, okay? Everybody see that? I mean, you could have gone, oh, if that's 5, I could do Pythagorean theorem. But why waste your time, right? If you know the relationship, it's a lot faster. So the hypotenuse would be 5 times the square root of 2. Got that? All right, let's we're gonna keep that on hold right now. Let's go to the 30, 60, 90 and do a little review of geometry. Okay. Now this triangle looks a little different because both sides aren't equal. You guys got baseball? All right, watch the video. Good luck. Where are you guys playing? Here? Who are you playing? Mount Pleasant. Okay. Well, beat them. All right, here we go. There's a relationship between here, 30, 60, 90. Why did I make that one 30? Because it's opposite the what? The shorter leg. See how that's shorter than this one? So the smaller angle is going to be opposite the smaller side. Everybody see that? So if I call that the short leg, what am I going to call this one? The long leg. Okay? And this is always what? The hypotenuse. So let's give some relationships here. Again, I don't know if you remember, but there's always a relationship to the short leg. All right? So on a 45-45, the hypotenuse was the square root of 2 times one of the legs. All right? The hypotenuse on a 30, 60, 90 is exactly twice the short leg. Remember that? All right? So again, if the short leg was 2, what would the hypotenuse be? Before. Easy, right? So it's just double. The hypotenuse is double the short leg. Now there's also a relationship between the long leg and the short leg. So the long leg is equal to the square root of 3 times the short leg. Now, understand, I don't know if too many teachers say this, but 2 is the same thing as the square root of 4, isn't it? Square root of 3 is just a little bit smaller than the square root of 4. Okay, so that's kind of how you can remember the square root of 3, because it's just the long leg is just a little bit smaller than the hypotenuse. All right, and so if the hypotenuse is the square root of 4, the long leg is square root of 3 times the short leg. Does that help? Might help a little bit to remember the square root of 3. That's a number you're going to have to remember. We're going to be using that number a lot. We're going to be using square root of 2 a lot, and we're going to be doing some stuff which we're going to do right now. So everybody got that in their notes? I'm going to push this up a little bit, and this time I will draw the triangle kind of nice. May not be exactly, but I'm trying to make those two sides the same. That's pretty close. That looks all right. All right, so this is 45 degrees, which means this is 45 degrees. All right, and yeah. So what they're going to do, let me see what they are doing here. Okay, so what I want to do is I want to find out, we don't know the length of this side, all right? I'm just going to make it x. Makes sense, right? If I don't know the length of it. So if this is 45, 45, what's the length of this side going to be right here? It's got to be x as well, because both sides are equal to each other, okay? So what I'm going to do is I'm going to find, let's do sine first. let's find the sine of 45 degrees. Without even knowing the lengths of the sides, I can figure out what the sine of 45 degrees is. Again, what are we doing when we're finding the sine of something, the cosine, the tangent of something? What are we doing? It's just a ratio. I'm just saying, if I got a 45 degree angle, what is the ratio between the opposite side and the hypotenuse? Okay? Off the cosine, what am I finding? I'm finding the ratio of the adjacent side to the hypotenuse. What's the tangent? The tangent is the opposite side over the adjacent side. I'm just trying to find a fraction. That's what a ratio is. Does that make sense? So when I'm finding the sine, cosine, and tangent, I'm just trying to find a fraction. Something over something else. Okay? Now, the sine is specific. It's the opposite over the hypotenuse. Problem is, I don't know what. Don't know the hypotenuse. But I can find it with what I just talked about. Do you remember what the relationship is? The hypotenuse is the square root of 2 times one of the legs. So it's going to be what? The square root of 2 times x. Everybody got that? You could have done Pythagorean theorem to find that, but it's better to do it this way. So now we got all our sides. Now I should be able to find the sine, cosine, and tangent. In fact, I'm going to find all 6 trig ratios, just like I did earlier, okay? So I've got the sine of 45. What else am I going to find? The cosine of 45. And then I'm going to find the tangent of 45. Let's do those first, and then we'll do the other 3. All right, I'll put them right here. So what is the sine of 45? It doesn't matter which 45 you use. Let's just use this one right here. All right, so what is it? It's opposite over hypotenuse. So the opposite is x over the hypotenuse, which is square root of 2, what? X. Let's simplify it. What happens here? The x and x's cancel. I'm left with a 1 on top. So now I got 1 over the square root of 2. I don't want to leave it like that. I want to multiply the square root of 2 times square root, or on top and bottom. That's it. Now, he just said it for the first time. We're going to say that dozens and dozens of times, maybe hundreds of times, okay? What is it? Square root of 2 over 2. That's a really important number when we deal with trig, all right? It's the first time we basically said it today, all right? So that's monumental, it really is, because when you're going to look back, you're like, man, we say that all the time. What about the cosine of 45? Well, cosine is adjacent over hypotenuse. It's the same thing, isn't it? Do I have to go through all the work again? Nah, because it's still x over square root of 2x. So that's also going to be what? Square root of 2 over 2. That's the cosine. What about the tangent of 45? The tangent is opposite over adjacent. So this is x over x, right? Opposite, adjacent, which is 1. And there you go. So now I got my 3. Let's do the other 3. I was going to do it over here, ran out of room. I'll just do them down here. I'll do them different colors, so kind of make them stand out. What's the inverse of the sine? What is it? Cosecant. Remember, it's not the same letter. It's the opposite letter. All right, so it's cosecant. So it's the cosecant of 45. Now you can do a couple things. All right, the cosecant is the inverse of the sine. The sine is opposite over hypotenuse, so the inverse is hypotenuse over opposite. You could do that. That would be perfectly fine. Or you could just look at what we had earlier, right, which was what? 1 over the, remember how we simplified that to 1 over the square root of 2? Or you could put the x there as well, right? X over square root of 2x. But now we got to flip it, right? Well, the x's cancel. Got a 1 on top. If I flip it, what do I get? Just the square root of 2. So the cosecant of 45 degrees is the square root of 2. Look, you could have flipped this one, but then you got more work to do, don't you? Right? If I flip this one, then I'd get 2 over the square root of 2, and then I'd have to rationalize the denominator, and then what would I get? 2 square root of 2 over 2. The 2's cancel. Boom, you get it anyway. But isn't it a lot easier looking right there and flipping it? Yeah. Or, like you said, or like I said, you could go hypotenuse over opposite. Square root of 2x over x. The x's cancel. Boom, square root of 2. However you want to do it. Okay. So next one. What's the inverse of the cosine? That's the secant of 45. Well, on a 45-degree triangle, the sine and cosine are exactly the same thing. That's kind of nice on a 45, 45, 90 triangle. So it's the same thing. So I just write square root of 2. No biggie. And the tangent, or I'm sorry, not tangent, but what is it? It's the cotangent of 45. It's just the inverse of 1. What's the inverse of 1? It's 1. And there you go. You got all 6. You okay with that? That's not so bad, is it? All right, now we're going to do the 30, 60, 90. All right, it adds a little bit of extra work, right? Because on here, sine and cosine were exactly the same. That made it kind of easy. On a 30, 60, 90, it's not going to be like that. They're all going to be different. All right, so let's do it. All right, let me draw a triangle again. It may not be to scale, but that's okay. So, oops. There we go. Let's push that over a little bit. That's close enough. That's 30 degrees. That's your 90. That's your 60 degrees right there. All right. So let's make the short side, since both of those things are related to the short side, let's make that an x. Okay. So if I make this side right here x, what's this going to be? What's the hypotenuse going to be? It's going to be 2 times, right? Because it's twice the shorter side. Remember that? Okay, that's why I went through that. So this would be 2x. What would the longer side be? Look in your notes if you need to. When we went over the 30, 60, 90 just a few minutes ago. You didn't write it down. It's not double. This is double. Why would this be double too? They can't be the same length. I even gave you a little hint. How did I tell you to remember? It's square root of 3 because it's a little smaller than 2. 2 is the same thing as square root of 4, right? So what's a little bit smaller than the square root of 4? 3. Okay, square root of 3. So this is the square root of 3 times the short leg. All right? That's why I did all that stuff earlier, so you could see it applied right here. Now, what are we doing? Finding all 6 trig ratios, all right? And we have to find all 6 with 2 different angles, right? Because before we only had the one angle, the 45 degree, right? So now we got to do it. We got to find the sine cosine tangent of 30 degrees, and we got to find the sine cosine tangent and their inverses, right, of 60 degrees. But I think this is good to do. It's good to do once, okay? This is not something you're going to have to do a whole lot, but it's good to see it once because you can see some of the relationships between the 30-degree angles and the 60-degree angles. So let's do the 30-degree angles first. All right, so we're going to do the sine, we're going to do the cosine, and we're going to do the tangent of 30 degrees. So this is 30 degrees, 30 degrees, 30 degrees. All right, so here we go. You ready? 30 degrees. We're doing this one right here. We're doing the sine. So what do we look for? We look for the opposite over the hypotenuse. So it's x over 2x. What does that simplify to be? No, it's not 2. Where is that 2? It's in the denominator. So the x's cancel, but it goes once, right? So it's 1/2. That's another one. Remember I said square root of 2 over 2 is important? 1/2 is also it's going to be one of those numbers that you're going to need to remember, all right? So square root of 2 over 2 and 1/2. Also 1 is important as well, like we did before for tangent. What about the cosine? The cosine's different. It's not the same as the sine this time. The cosine is the what? Adjacent over the hypotenuse. So this is the square root of 3x over 2x. This works out kind of nice. The x's cancel. What do we get? Square root of 3 over 2. Just like I said, the square root of 2 over 2, super important. We're going to say it dozens, maybe hundreds of times. Same thing with square root of 3 over 2. All right, that's another number that's really, really important that we're going to use a lot. All right, square root of 3 over 2. We good? Let's do the tangent. Opposite over adjacent, right? So what's the opposite? X. The adjacent is the square root of 3x. Might be able to do this in your head, right? You know the x's cancel. You got a 1 on the top. Can you do this in your head? Yep, square root of 3 over 3. Good. That's another number, okay, that's going to be really popular. So square root of 2 over 2, 1/2, square root of 3 over 2, square root of 3 over 3. Those are going to be really important for us, okay? Now we got to find the, let's go orange. I discovered orange in my other class today, so we'll do this. What's the inverse of the sine? It's cosecant, okay, of 30 degrees. Why did I make that a theta? I don't know. Cosecant equals, oh, it's not equals, just the cosecant of 30 degrees. All right, I'll get straight here. It is the end of the day, right? So the cosecant is the inverse of the sine. So the sine was 1/2. What's the cosecant going to be then? You can just do that in your head. What is it? Just 2. All right. Again, it's not 2 degrees. It's just the number 2. All right. There's your degrees, your angle right there. What's the inverse of the cosine? The secant. So that's the secant of 30 degrees. This is a little, you got to do a little bit of math here. This is a square root of 3 over 2. Or you could do this. You could say, what's the secant's the inverse of the cosine. The cosine was adjacent over hypotenuse. So what's the secant? Hypotenuse over adjacent, right? Well, you're still going to get the same thing. It doesn't matter. You still got to simplify. So it's going to be 2 over square root of 3. Let's simplify this in our head, can you? You got it. 2 square root of 3 over 3. All right? I mean, you'll see that once in a while. To tell you the truth, they don't use the inverse stuff near as much as they use the regular trig ratios. All right, so yeah, you will see that, not near as much. What about the tangent? Well, it's cotangent, isn't it? Cotangent of 30 degrees. So what was it? It was 1 over the square root of 3, wasn't it? So what is this? It's just the square root of 3. All right, so there's my 6 trig ratios for 30 degrees. Does that make sense? Yeah. I'm going to erase this, but you don't erase it. Everybody got that down? All right. Just to give me some room, I don't have to redraw that triangle. Is that all right? Boom. There it goes. All right, so now what am I going to do? 60 degrees, right? And is this the last thing we're doing? It's pretty close to the last thing we're doing, so we got time. That's good. Let's see, 60 degrees, right? Just like this. And so we're going to do the sine of 60. Oh, you know what? I should have kept it up there. I want to keep them up there. Okay. Good thing for Control Z, right? Let's, I'll move it up. I'll tell you what I can do. And good thing for Control C. Well, I kind of got some of that other stuff in there. I'll get rid of it in a second. So I'll keep that there for a minute and then put this here. Get rid of some of this nonsense right there. All right, there we go. Push this over. All right, everybody ready? So let's do 60 degrees. And we're going to do the sine of 60, cosine, tangent. All right, we'll go a little faster this time since we're kind of getting the idea of this. Are you getting the idea of this? Okay, good. Sine of 60. Sine is what? Opposite over hypotenuse. So it's the square root of 3x over 2x. Bam, bam. And look what we get. We get the square root of 3 over 2. I want to show you something now. This is why I wanted to keep this up there. Look, the sine of 60 is the square root of 3 over 2. Do you see any other square root of 3 over 2? Yeah, look at it. It's the what? It's the cosine of 30. So the sine of 60 is the same thing as the cosine of 30. So what's the relationship between the 60 and the 30? Nobody? They're complementary angles, okay? They're complementary. We talked about that word yesterday, didn't we? They add up to 90 degrees. Okay, so if you have a trig ratio and you know it, right? If you take the complement of it and take the other trig ratio, right? If it was sine, then you take the cosine, it's going to be the same exact number. So that's kind of nice to see. That's why I wanted to keep that up there. All right, you with me on that? So look at this. The cosine of 60. It should be the same thing as what? Something we've already done. The what? Everybody think. Come on. Day's not over yet. Still got 12 more minutes. The cosine of 60 should be the same number as, what did I say? No, the opposite, the other trig ratio. The sine, right? The sine and cosine kind of go together, right? So it's the other one, which is the sine of what? 30 degrees. What's the sine of 30 degrees? It's 1/2. You see it? Let's see if it actually does work that way. Okay, don't just take my word for it. Let's see if it does. So the cosine of 60. So it would be adjacent over, right here. Adjacent over hypotenuse. That's x over 2x. Sure enough, look what we get. That goes once, right? 1/2. Isn't that the same thing as the sine of 30? Yeah? All right. Guys look thrilled to death, I tell you. The tangent of 60. Let's do the tangent of this angle up here. What is that? It's opposite over adjacent. So that would be the square root of 3x over adjacent, which would be x. And the tangent of 60 is square root of 3. See that? What was the tangent of 30? It was the square root of 3 what? Over 3. All right, this is something that you're going to have to memorize a lot of these numbers and know which one goes with what. All right? So if you're walking down the hallway, I might tap you on the shoulder and I'm like, look, quick, you got to tell me what is the tangent of 30 degrees. All right? And it's square root of 3 over 3. Do you see the relationship between that one and this one? See, this one's bigger, isn't it? Because I'm not dividing by 3. Agreed? So the bigger one, the square root of 3, goes with the bigger angle, goes with 60. All right? The smaller one, square root of 3 over 3, goes with a smaller angle, 30 degrees. You see that? All right, so it's just a good way to kind of remember. You know you're going to use square root of 3. One of them's going to be over 3. One of them's just going to be 3. All right, so which one goes with what? Tangent of 60. Oh, 60 is the bigger number, right? So it's just going to be square root of 3. Tangent of 30. Oh, that's the smaller one. So what goes with tangent? Square root of 3, what? Over 3. These are things that it makes life a lot easier if you memorize these. But not just memorize them. Think about what they look like in the triangle. All right? All right, almost done. Let's change colors a little bit. Let's do the inverse ones. Okay, so what's the inverse of the sine? That would be the cosecant of 60. And what do? Just flip it, right? I don't know. Can you do this in your head without even writing it down? I'm going to write 2 over square root of 3. That's it. It's going to be 2 square root of 3 over 3. Okay? Are you getting better at that now? Secant of 60. Yeah, you just flip this. It's easy. It's 2. I don't really have these memorized. These inverse ones, I don't have them memorized. I think which one they go to. I got the other ones memorized, and then I just flip it. All right? I guess you could memorize them. That'd be fine, I guess. What is this one? Yes. So this would be what? Cotangent of 60 degrees. So it's going to be, I flip this, so it's 1 over square root of 3. And if you change it, rationalize the denominator, you get square root of 3 over 3. And there you go. There are your trig ratios with those special triangles. And those special triangles show up quite a bit. All right? Yeah, let's talk. I got some time, so I'm not going to do any more examples. Just going to write down a couple things. You know how I said that the sine of 30 and the cosine of 60 kind of go together? There's actually a name for it. All right? And these are called cofunctions. Cofunctions. All right? So let's think about this. Let's do this. So the sine of 30 degrees would be the exact same thing as what? The cosine of what? 60 degrees. Very good. Everybody with me on that? All right. I mean, we can use other numbers as well. All right. But 30, 60, 90 is a pretty special triangle. We're going to do that a lot. And you could do this. What's the cosine of 30 degrees? What's that equal to? That's it. That's the sine of 60 degrees. You with me? Those are called cofunctions. There's another way that they write it. Watch. The sine of something. I don't know why I didn't put a theta on that one. Yeah, it needs a theta. All right, so the sine of an angle is equal to the cosine of what in general, if that's just a general angle. Because it doesn't always have to be just 30 and 60. I could have like a 21 degree angle, right? And what's complementary of 21? 89? No, not 89. 21, 90, 69, right? Yeah, okay. Do the math. 60, 80, is that right? Yeah, that's right. So it could be any angle. But what do I do? What math was I doing here? Look, how did I get from 30 to 60? How did I get from that 30 to, well, it was the same thing. I did what? I went 90 minus what? No. How did I get from here to here? I went 90 minus 30, didn't I? All right. What if the angle is 21 degrees? How do I find the cofunction of it? It's 90 minus 21, okay? So if this is theta, I don't know it's 30, I don't know it's 60, I don't know it's 21, I just know it's theta. So what's this going to be? You got it, 90 minus theta, okay? So the sine of an angle is equal, and what is this? This is its complement, right? Complementary angles, yeah, that's right, M-E-N-T, all right? That's its complement. 90 minus theta is its complement. So the sine of theta equals this. How would I write the cosine of theta? That's equal to what? The sine of its complement. What's its complement? 90 minus theta. You with me? Let's do a third one. Tangent. What's the tangent? Would be what? What's the inverse, or what's the other one that goes with, let's see, hold on. Yep. This would be what? This would be the cotangent of 90 minus theta. All right? What about the secant? What if I go to the secant of theta? What do you think that is? Whoops, forgot something. It's going to be the cosecant of what? 90 minus theta. You getting the idea? And then what if I put cosecant of theta? What's that equal to? It's equal to the secant of its complement, which is 90 minus theta. There you go. So that's that. We finished that lesson. It looks complicated. I mean, if you would have walked in the door a week ago and then saw all this mess right here, you're like, oh my goodness, what are we in for? Okay, I'm not going to be able to do that stuff. But after you see it, it starts making a little bit more sense. You know what the theta means, you know what the cosecant means, and all that kind of stuff. All right? I don't know if that makes it better or not, but that's how it goes. So now I am officially assigning this homework. Yesterday I said you could start on some of them. Did anybody actually do that? Well, I was going to say, well, it was on YouTube, but I forgot to put it on YouTube yesterday. Did you even look to see if it was on there, though? Did you? Okay, good. Yeah, sorry. I didn't even take my computer home. That's very rare. I always take it home every night. Last night I said, I'm taking a break. But I thought I uploaded it. This will be uploaded. I'll do it as soon as you guys leave. So both of those will be up online before 3:30 probably. All right, so there it is. That's your homework. That is due tomorrow. Everybody good? All right.